Hello, everyone. My name is Mark Bannon, and I'm an author. I write fantasy and science fiction novels. And welcome. I want to welcome you to my panel on the nearest stars. These are all the stars within 100 light years. So I came to this as a game designer. I'm a game designer and an author. So I came to this as a gamer. And here's an interesting question for you. What's the longest running science fiction series? Anyone know? It's Perry Rodin, which is German science fiction. So they have 150 million words worth of stories. They started in 1960, and they've been going. They're still going, and they write a novel every week for 60 years now. So that's just an interesting bit of trivia, right? So here's the game Traveller. If you ever played role-playing games, and got into science fiction role-playing games, this is probably what you were playing. And Traveller was a really great game. And here's one of the starships from the Traveller universe. Someone made a 3D rendering of it. And here's the map of the universe in Traveller. And it's a really beautiful looking map, and it's cool and everything, but it's not real. And you know, if you're a science fiction writer, you might want to be maybe use real stars. That's what I like to do. I like to use a real stars in my fiction. So here's a overview of the Milky Way. Milky Way is 100,000 light years in diameter and 1,000 light years thick. So it's literally I guess 100 times wider than it is thick. So if you want to exit the galaxy quickly, you go up or down. And it's like a flat disk. So a lot of the older civilizations called the Milky Way the River of Heaven. Fun name for it. There are 100 to 400 billion stars in our galaxy. So even if there are, let's say maybe 200 or 300 billion stars, and let's say 1 out of 1,000 has a civilization attached, then that would be 1 million civilizations in our galaxy. So the center of the galaxy is a massive black hole, Sagittarius A, and it's 26,000 light years away. This is just kind of an overview of the region, where we live. And you can see at the top of the screen, here's the sun. We're right up here, and then there's a black hole at the center of the galaxy. And it's, again, 100,000 light years in diameter. These are the constellations, and pretty neat to have a constellation map. But some interesting things come up when you look into this. Not everyone uses the same constellations. In India, for instance, they divide the heavens into 27 regions called nakshatras. And that's different. And in China, they have something called enclosures. They have 6 enclosures. It's sort of like they divided into major regions of the sky. So you have the azure dragon of the east. You have the black tortoise of the north. You have the white tiger of the west, and the vermilion bird of the south. And also, if you look straight up, you have the purple forbidden enclosures. And if you go down, they didn't really know anything below the horizon in China, so they didn't have anything in the southern hemisphere. But now modern astronomers call it the southern asterisms. And asterism is just another word for a constellation. So they're the southern asterisms. So we don't even agree on our name of our planet. So, you think the Earth in science fiction is all Earth, 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 but, in other countries, they use different names. The Latin call it Terra, the Greeks call it Gaia, the Chinese call Earth Dishu, and in India, they call it Prithvi, right? Also, the name of the sun is not the same. It's Sol in Latin, Helios in Greek, Taiyang in Chinese, and Surya in India. So we all have different names. And that's interesting. So then you have, this is how you find a star. So this is how you build the database. And I built a database, and I'll share it with you guys a little bit. So you use right ascension and declination and distance. So right ascension is it's in 360 degrees and it goes around in a circle. It's kind of like longitude lines. And then declination is your angle up or your angle down. So plus 1 to 90 degrees or minus 1 to 90 degrees if they're below the plane of where the Earth is. So that's right ascension, declination, distance. And this is how to read a star chart. So up at the right, you have the right ascension numbers 80, 90 degrees. It starts in the middle, right? So 10, 20, 30, these are degrees up, and then these are degrees down if you're looking on the right side of the screen. And you start from right to left, that's right ascension. So like, let's say 9 degrees, right ascension, and minus 30 would be the constellation Pyxis, I think it is. So that's, and that's how you locate at stars, and that's how you read a star chart. So these are measuring systems. This is interesting. All the measuring systems we use are based on Earth and our own solar system. So the Earth is, 1 year is 365 days. And an astronomical unit is about 150 million kilometers. And that's a distance, the average distance from the center of the Earth to the center of the sun. It's an elliptical orbit, so it's not exactly circular, as far as I remember. And so that's astronomical unit. A parsec is another distance they use, and that's basically the distance to an object whose parallax angle is 1 arcsecond. And they use that. I prefer light years. Oh, by the way, a light year is 3.26 light years in 1 parsec. So the speed of light is about 300 million meters per second, or about 300,000 kilometers per second, or 186,000 miles per second. And so most of the distances are used if you're using light years instead of parsecs. It's how long light takes to travel in a year. So light travels about 9.5 trillion kilometers in a year. And so that's, since it's traveling 300,000 kilometers per second, the light takes about 1.3 seconds to get to the moon. From the sun, it takes over 8 minutes for the light to reach Earth. And Alpha Centauri is 4.4 years. And the Hercules cluster, M13 cluster, is 25,000 light years away. The Andromeda galaxy is 2.5 million light years away. And this is what Andromeda would look like if it were visible, if it were brighter, and if it were visible in our sky. That's the moon to the left, and that's what Andromeda would look like. So that's how big it is, even at 2.5 million light years away. So another thing that's interesting is light from the sun takes about 5.5 hours to reach Pluto. So if you're writing a science fiction story and you have some spaceships enter our solar system, where they're going to be invisible for 5.5 hours before it gets to us. The light from them will reach us. So kind of interesting. So these are the stars within 12.5 light years. This is from a website called atlasoftheuniverse.com. Great website. In fact, there's another one called Sol Station, and they have a lot of good stellar data. And so that's 12.5 light years. Here's 50 light years, how all the stars in 50 light years. And here's the stars within 250 light years. This is a quick overview, right? So also here's something that's interesting. People who write science fiction, they love to put battles, especially when they're making movies, they love to put battles in nebulas. Well, the closest nebula to Earth is 700 light years away. So it's not even inside the sphere I'm talking about. So I'm just doing 100 light years. And so there are no nebulas in that area, no nebulas like this. So this is the Helix Nebula. So these are different kinds of stars. The OB, AF, G, KM, and M is the colder ones, and the blue ones are really hot. So if you're figuring out the chance of life to be in the system, they have an area called I think it's called the Goldilocks zone. It's a habitable zone area, and it moves further away the hotter the star is. And if it's a red star, it'd be so close to the star, it'd be like the orbit of Mercury around our sun. It'd be very fast, and a very short year they would have. And so, and the habitable zone is basically where water can exist. So if you can't have water, they're thinking maybe there's no other kind of life. Now, they don't know. There may be other kinds of life. Science fiction author or writers can play with that. But this is just what we know so far. So these are how many stars of each type are within 100 light years. We don't have any type O stars. We do have 4 blue B stars, 76 type A stars, 303 F stars, 514 yellow stars. So let's just say you're writing a story and only yellow stars are going to have life. Let's just say you've only got 514 possible locations where you can have a civilization, right? And then 946 orange stars and 1970 red stars. That's about half of the amount of stars within 100 light years are the cool M stars. And then there are a few other stars that are not sure what the distance is to the location, and so they haven't verify the data. So it's a lot miscellaneous. So there are 3,946 stars within 100 light years. Here's my database I've been building. And if you'd like a copy of this, send me an email. My email is marktheanimator@gmail.com. And I like to color code them. So most of the stars you can see are red, and I use distance in light years. Also have distance in parsecs, and how many stars, 1, 2, or 3 in the system. And I'm using right ascension declination, right? But all the numbers are based on hours, minutes, and seconds. So like this will be 17 hours, 57 minutes for Barnard star, and 48.4 and change in seconds. That's for the right ascension. The declination is up and down, right? So minus 62 under Proxima Centauri means that it's below the plane that we're on, so it's minus. So anyway, and then I have the math figured out. So when you're doing right ascension and declination distance, you have to calculate. You have to basically convert the hours, minutes, and seconds into a digital number. Then you have to plug it into these math formulas, and Excel will take the formulas, which is really nice. And it'll generate the XYZ coordinates, and then I have the constellation on the right. So using this kind of data, you can build your map of your own civilization if you're going to do that. And this is my world I'm creating. It's called Imperium, and I've got the names of the colony, and that's just made up, of course. And then it's got all the data in there. And then further right on the database, there's the XYZ coordinates, and then the constellation, and then I have the symbol or the enclosure, the Chinese enclosure, like Azure Dragon of the East, for instance. And then I also have the nakshatras listed in the database. And what's interesting, if you go to the far right of the chart, number of planets this is made up. The H planets and N planets, that's what we've discovered. And also, if the scientists have figured out the habitable zones in the different stars, and if a planet were to exist in the habitable zone of that star, this is how long their year would be. That's what the number on the far right is. So that's basically my database. I'd be happy to send you the database. You'd also get a map of my that I've been creating on my website, thesolarimperium.com. And so here's the map I've created for my universe, and it's incomplete still. I'm still building it. I figure I'll take another 500 to 1,000 hours to finish it, because I got to type in all the data, and I got to look up the constellations, and it takes a long time. So here's another map of another view of it without the nakshatras there, so it's a little bigger to see. The best resolution you can get by going to my website, and you can see it there. So if you'd like to help me build the database, send me an email, marktheanimator@gmail.com. You could go to solarimperium.com, and you can see the map. And I haven't put much other content on the website, but I'm getting to it. And also, if you'd like the database, just say, please send me the database. I'll be happy to send you my database, and you can play with it yourself. So anyway, that's what I have for you. Thanks very much. And